Hi students. So in this session, we are going to discuss how we can perform the convolution of two discrete sequences. Okay, so we are having two signals, let x of n and then h of n. H of n will be the system impulse response. Okay, so this is since this is discrete, we will be given discrete values are for x of n and then h of n. So we are going to convolute these two sequences. Okay, so it will be like so we are having two sequences. Okay. So first let the starting point of the first sequence, that is x of n, will be n1. So that is starting point. That first sequence x of n will be starting from n1 and h of n will be starting from n2. Then the resultant or the convoluted sequence should be start from n is equal to n1 plus n2. Okay, so this is the first step. We need to find the starting point of the convoluted sequence. Then we need to find, this is not given in this point, but we need to find the length of the convoluted sequence. Say like the length of x of n will be L1 and the length of h of n will be L2. Then the result length of the convoluted sequence will be L1 plus L2 minus 1. Okay, so that is L1 plus L2 minus 1. Okay, so we know the starting point, which is n1 plus n2, and from n1 plus n2, there should be how many samples? L1 plus L2 minus 1. So that much sample should be available in the convoluted sequences. Okay. So initially we are given the signals in terms of with the index n, and for this convolution we are changing the index to k. Okay. So the next step is we are drawing that sequences x of n and h of n. Next step, we are folding or we are time reversing the signal h of k. That is, we will draw h of minus k. So we know that how to uh, perform these actions. We already studied in module 1. So we draw h of k, then we draw h of minus k. Okay, so then we are going to plot h of n minus k's. Okay, so we know that n is the point which the sequence appears. Okay, so we know how we will get n. N we will get the starting point as n equal to n1 plus n2. Then from that point n1 plus n2 we are counting how many samples? L1 plus L2 minus 1. That much sample we will count, and that much sample will be available in the convoluted sequence. So the first value of n will be n1 plus n2. Okay, so for if that n is negative, we will be uh, shifting h of minus k to uh, left, and if n is positive, we are shifting h of minus k to where? Right side. Okay, so first we will draw h of minus k, then we will plot h of n minus k. So n is n1 plus n2. Then we are incrementing that values for n. Okay, so we are incrementing. Say for example, we will get n1 plus n2 as minus 1. Okay, so first time after drawing h of minus k, we will draw h of minus 1 minus k. Okay, so in order to draw h of minus 1 minus k, we need to shift the h of minus k to the left by one position. Okay, so if it is minus 2, we need to shift h of minus k to the left by two position. Then we need to draw h of next point. That's if it starts from n1 plus n2 is minus 1, then next point is 0. That is minus 1 plus 1. It is 0. So we need to shift the first term, that is h of minus 1 minus k, to right by one position. Then we will increment h of n by 1 point. That is, if initially we start from minus 1, then next value is h of 0 minus k, then next value is h of 1 minus k, then h of 2 minus k, h of 3 minus k. From that point to where n1 plus n2 to from how many samples we require? N1 plus N2 minus 1. Okay, so until we continues this process until we will get uh, okay, after finding each of these values for h of n minus k, where each step we are multiplying that h of n minus k with the x of k value. And we continuing this process until we get uh, the all the multiplication. After multiplying each time we need to add together multiplication and addition. So until we continue this process until we will get a complete zero at the output. Okay, so let's see one example. Okay, so here they're asking us to determine the convolution sum of two sequences. So they're giving us two sequences h of n and x of n, and x of n is 1 4 3 2, h of n is 1 3 2 1, and here they are denoted one arrow. It shows the value corresponds to 0. 0, that is n is equal to 0 ലെ value ആണ് കാണിച്ചേക്കുന്നത്. And from this it is 4 is the value for 0, then we know that 1 will be corresponds to the value of minus 1. So from this we can say that x of n starts from minus 1. Okay, so in case of h of n they are not specified the start value for 0, so we are assuming 1 is the value corresponds to n equal to 0. Okay, so now first step we need to find from where the convoluted sequence should start. So it should be equal to n equal to n1 plus n2. So we know that n1 is minus 1, n2 is 1, sorry, n2 is 0. So the total value n1 plus n2 will be equivalent to minus 1 comma 0. So the minus 1 is x of n starts from minus 1 and h of n starts from 0. So from that we got the initial point of the convoluted sequence is minus 1 plus 0, that is minus 1. So the y of n should start from minus 1. So from minus 1, how many samples should be there? So we know that the length of the sequence x of n is 4 and h of n is 4. There should be how many samples should be available in y of n? It is 4 plus 4 minus 1. So that is 7 samples. So from minus 1 to 7 samples. How many are there? From minus 1, 0, 1, 2, 3, 4, 5. So we need to find the values corresponds to y of minus 1 to y of 5. So let's see. So we are changing the index to k and we are drawing x of k and h of k. Okay. So x of k, h of k, we are drawing. We know how to draw discrete signals. Then next step is we are drawing h of minus k. Okay, so h of minus k will be like this. That is, we are just writing the mirror reflection of this h of k. Okay, so then next step is we need to do h of first term n minus k. So n is starts from minus 1. So that is h of minus 1 minus k. Since n is negative, that is we need to shift the h of minus k to the left by n terms. So here n is minus 1 and it is we need to shift h of minus k to the left by 1 term. So it is starts from initially h of minus k starts from minus 3. Here it is minus 4. Okay. So then each step we are multiplying this. Next step we need to multiply x of k into h of minus 1 minus k, like that. Okay, so we here it is our x of k. This is first value corresponds to h of minus k minus 1. So we know that how to multiply this discrete values, that is it starts from minus 4. Here also we need to multiply each term from minus 4 to 2. Okay, so here it will be like, what is the value of minus 4? Here it is 1. So 1 multiplied by 2 multiplied by, here it is 0. So 0, then 0. Next point also 0, but here we are having 2. Like that we are multiplying and adding together we will get 1. Next step we are incrementing the value of n. So from minus 1 to next value will be 0. So 0 minus k is, so minus k. So we will get like this. Then again we are multiplying x of k by h of 0 minus k. Okay. So multiplying each sequence and adding together we will get 7. Then we are shifting the minus k nearby one position. So it will start, initially it starts from minus 4 and the second step it starts from minus 3, then it is to minus 2 and we are multiplying x of k and h of 1 minus k, and adding each signal together, we will get it is 17. Then again we are shifting h of k, h of that will be h of 2 minus k, and multiplying x of k into h of 2 minus k, and multiplying each signal and adding together, we will get it is 20. Okay, so we are repeating this process until we will get a 0. So till x of 5 we will get a value. So what happens, y of 6, in case of y of 6, the signal will starts from 3, h of 6 minus k. So it is from 3, we need to multiply with the x of k. So let's see, uh, here it is starts from 3. Okay, next one is 3, but from 3 onwards there is no signal is available in x of k. So whatever the term comes, it will become 0, and we will get x y of 6 as 0. So we need to consider that we need to draw the signal up to x of 5. So we need to rewrite that signal. The convoluted sequence y of n will be equal to curly bracket first term 1, 7, 17, 1 comma 7 comma 17 comma 20 comma 16 comma 7 comma 2, and we know that the convoluted sequence starts from minus 1, and we should put a arrow under the value of 0. So it is 7, we should put a arrow under 7. Okay, so this is how we are performing graphical convolution.